Alright, you're welcome back to the channel. It's always so good to have you here. Welcome, welcome, welcome. I am Pendulum, and this is Pendumatics, the complete online school of mathematics, where we try to break down different topics in maths, making it as easy and as fun to learn as possible. Alright, so we are still looking at set theory, but today we will be going into 3 sets Venn diagram problems. 3 sets. We've done 2 sets, so let's look at 3 sets. This will be the part 1 of this video on 3 set problems. Alright, so welcome. If you're new, do well to subscribe to this channel and then ring the notifications bell once you subscribe, so that whenever we drop a new video on any topic, you'll be notified immediately. Alright, so welcome, welcome, welcome. Okay, so we have 2 examples we'll be looking at in this video. I'll try to be as fast as possible, and as we go through this video, if you find it helpful, if it's clear, and just drop a like on the video, drop your comments as well, so that I know what you think about the video and if you have any questions. And then don't forget to share this video to your friends, to your colleagues, to your classmates, and everywhere and everyone you can share the video to. Alright, so let's look at the examples. This is example 1. It said, in a certain class, 25 students offer maths, 16 offer English. Let me be writing it down. Number of students that offer maths is 25. Number that offer English is 16. Okay. Number that offer biology, 21 people offer biology. Then we're told that 8 students offer maths and English. So number of students maths intersection English is 8. Okay, 11 offered maths and biology. So number of students in maths intersection biology is what? 11, and then 7 offer English and biology. So English intersection biology 7. Okay, we are told that 3 students offer everything. So that would be maths intersection English intersection biology. 3 students offer everything, while 4 students do not offer any of the subjects. So these 4 students will be outside these 3 sets. They are still part of that class, so they are still part of the universal set, but they will be outside these 3 sets. So we write it like this: M union E union B complements. So everything outside these 3 sets, but still a part of the universal set. Alright, so if I'm drawing the Venn diagram for this, should be something like this. So I have maths, I have English, and I have biology. I told that maths, 25 people offer maths, 16 people offer English, 21 people offer biology, 8 people offer maths and English. Alright, so that means, okay, first of all, 3 people offer all 3 subjects. That's this middle. Alright, that's all 3. This is where the 3 sets meet. So that place is 3, because we are told that 3 people offer all 3 subjects. Now, 8 people offer maths and English. The intersection between maths and English is here. Okay, but let me draw it down so that you see. This is maths, this is English. The intersection between maths and English is here. Okay, so this whole place is 8, because 8 people offer maths and English. This whole place is 8. Alright, but then we can see that a part of this is 3. A part of this intersection is also part of the intersection of the 3 sets, which is 3. So that means if this whole area M intersection E is 8 and this part is 3, what will be this remaining part? What will be this shaded part? By common sense or common logic, if the whole area is 8 and this part is 3, this remaining part will be 8 minus 3, okay, which is 5. I hope you got the explanation. This whole place, M intersection E, is 8. So if this middle is 3 that we are told, this remaining part will be 8 minus 3. Alright, so the same thing goes for the other ones. Number of people in M, that's mass intersection biology, is 11. 11 students offer mass and biology. So this whole place is 11. But if I remove 3, this remaining place will be 8. Okay, obviously 8 plus 3 will still give you that 11. So this place will be 8. 11 minus 3. And then the intersection of English and biology, 7 people offer English and biology. So that means this whole place is 7. 7 minus 3, this remaining place is 4. Alright, so what else are we told? 4 people don't offer any. That means, like I said, they are outside these 3 sets, but they are within the classroom. So let's just put it here. 4 people don't offer any subjects. So we are asked to find how many students are in that class. That's what we are looking for, which is our universal set. So the universal set is what we are looking for. We don't know the universal set. Okay, now I told you, if you've watched the video on 2 set problems, I told you that all you need to do is add up everything within the sets and equate it to the universal set. What I mean is, now we know here, we know here, we know here, we know here. Okay, we need to find this place, and this place. This part is those that study mathematics alone. Alright, this whole circle is mass. Okay, this is math and English, this is math and biology, this is math, English and biology. We need to find those that study mathematics alone. Those that study mathematics alone. Alright, that will be here. This is those that study English alone. This is those that study biology alone. So number of people that study math alone or only will be, the total number of people that study math is 25 minus, we'll remove this 3, 8, 5, 3. Okay, remember the whole circle is 25, right? That is the number of people that study math. Then this part is 8, we'll subtract it from 25. This part is 5, we'll subtract it from 25. The middle is 3. We'll have to subtract all those things to be able to get math only. Those that study math only. Alright, so this will give me 25 minus 8 plus 5 is 13. 13 plus 3 is 16. 25 minus 16, which will give me 9. So 9 students study math only. The same thing we'll do for English only. Now English, the total number of people that study English is 16. So 16 minus, then we'll subtract 1, 2, 3. We'll subtract 5 plus 3 plus 4. This is 16 minus 5 plus 3 is 8 plus 4, 12. And this is 4. So 4 people study English only. And then how many people study biology only? That will be, total number of people that study biology is 21 minus, subtract these 3 intersections, 8, 3, 4. 8, 3 and 4. Let's give it 21 minus 15, right? And this is 6. Okay, so what I've done here is not rocket science. It's not so difficult. If we know that 25 people study mathematics in the class, Okay, but out of those 25 people, we have some people that study mathematics and English. We have some people that study mathematics and biology. We also have people that study mathematics, English, and biology. Now, I come and I ask you, okay, in this class, I want to know those people that are only offering mathematics. They are not doing English, they are not doing biology. How do you get it? You bring out everybody that study maths in that class, both those that study maths and those that study maths with other subjects, and then you remove, subtract those that have other subjects attached. What you are left with will be the people that study only maths. So that's what we just did here. 25, the total for those that study maths, minus this intersection with English, this intersection minus this intersection with biology, minus this intersection with two of them. Okay, do it for the rest. Now we have filled up this set. We have filled up here, we have filled up here, we know 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 here, and we have something outside. Now note that this one outside may not always be there. Okay, there are some cases where there is no term outside the set. In that case, you leave it, okay, or you assume it to be 0, which is the same thing. But now, like I told you, if we add up to find our universal set, if we add up everything here, this, and this, you get a universal set. So therefore, u will be 9 plus 5 plus 4 plus this second 4 plus the 3 in the middle plus 8, then plus this 6 plus 4. Please don't add this 25, this 16, or this 21. No, please, we use these ones to fill in the sets. All right, remember, you are going to add those who do maths only, plus those who do maths and English, plus those who do English only, plus those who do English and biology, plus those who do maths and biology, plus those who do biology only, then plus those who do all three subjects. So take care that you don't add these ones. Just fill in the sets, fill in the spaces, and then add everything within the sets. All right, if you have a complement, that's something outside the set, this one that's on its own, you add it as well. If you don't have, you leave it, but don't add these total figures, please. Take note of that. So what would this give me? This is 14, 18, 22, 25, 31, 39, 43. Is this correct? Let me confirm, please. This is 10, 18, 22, 26, 31, 40, 43. Okay, so 43 is our universal set. That means 43 students are in that class. Remember, that's what they were asked to look for. 43 students are in that class. Okay, so this is the answer to the first question. It's quite simple, and I believe it's something you can do. All right, so let's do the second one quickly. If there's any question here, you can put it in the comments and I will respond to it. But let's do the second one quickly. Okay, so let us look at the solution to example 2. I'll solve it here and here. All right. Then the question says, in a community of 40 people, that means our universal set is 40. 25 speak Hausa. Number of those that speak Hausa, 25. 16 speak Igbo. Number of those that speak Igbo, 16. 21 speak Yoruba. Number of Yoruba, 21. And everyone speaks at least one of these languages. So that means in this case, there is no complement. There is nobody in that community that will be outside these three sets of Hausa, Igbo, and Yoruba. Everybody speaks at least one language, so there's nobody there that does not speak either one of these languages. So what it means is that for this question, you will not have something like this. There is nobody outside the set. There's nobody that doesn't speak one of the languages. So take note of that. Now, 8 speak Hausa and Igbo. So number of elements Hausa intersection Igbo is 8. 11 speak Hausa and Yoruba. So Hausa intersection Yoruba 8. Sorry, 11. 11, and then 6 speak Igbo and Yoruba. Igbo intersection Yoruba 6. Now you are asked to find how many people speak all 3 languages and how many people speak Igbo alone. All 3 languages means Hausa intersection Igbo intersection Yoruba. Let's call that X. Alright, so if we draw the Venn diagram of this, okay, we have something like this. Our universal set is 40. Okay, now we are told that Hausa is 25 people, Igbo has 16 people, Yoruba has 21 people. Okay, then we are asked to find people that speak all 3. Remember, all 3 is always this middle. Since we don't know it, in this case, we'll call it X. People that speak all 3 languages. Okay, then going further, number of people that speak Hausa and Igbo, they say is what? 8. 8 people speak Hausa and Igbo. Now, just like we did here, this whole intersection is the intersection of Hausa and Igbo. Okay, and this whole intersection is 8. But then a part of it here is X. That means this part that remains will be 8 minus X. We'll just remove X from 8 to get this remaining part. Alright, so if this whole intersection is X, is 8. 8 people speak Hausa and Igbo, and this part is X. The remaining part here will be 8 minus X. Alright, and then you have Hausa intersection Yoruba, 11 people. Alright, so if this whole intersection, this Hausa, this Yoruba, this whole intersection is 11, and this part is X, here will be 11 minus X. And then for Yoruba and Igbo, 6 people speak Igbo and Yoruba. So this entire intersection is 6. If I remove this part that is X, I will be left with 6 minus X. Alright. So, like I told you, what you need to do, first of all, fill in these parts. If you fill in these parts, then you are on your way to solving this question completely. So let us fill in this part. We need to find this part is people that speak Hausa alone, people that speak Igbo alone, people that speak Yoruba alone. Now, how do I find people that speak Hausa alone or Hausa only? The same thing we did here. It will be this total number of people that speak Hausa, 25, minus this plus this plus this, just like we did here. So minus 8 minus X plus X plus 11 minus X. 25 minus this minus this minus this. Alright, if you look carefully, plus X will cancel minus X here. Plus X minus X is 0, so those two will go. So we are left with 25. Now 8 plus 11 is 19. 8 plus 11 is 19. So 25 minus 19, then minus X. If I open this bracket, 25 minus 19 plus X, which is, remember, minus times minus is how this one became plus. 25 minus 19 is 6 plus x. So number of people that speak Hausa only is 6 plus x. Okay, I do the same thing for Igbo only. Now Igbo is 16 minus this plus this plus this. So I'm removing all the intersections from people that speak Igbo. Okay, every other intersection with any language, I'm removing it so that I can get Igbo alone. Okay, so again, plus x will cancel minus x. I'm left with 16 minus 8 plus 6 is 14, and then minus x. If I open up, I have 16 minus 14 plus x, which will give me 2 plus x. So this is 2 plus x. And then for Yoruba only, I have Yoruba is 21 minus, I'll add this, add this, add this. I'm removing these 3. Okay, so I'm removing 6 minus x plus x, then plus 11 minus x. Minus x and plus x will cancel out. We are left with 21 minus 6 plus 11 is 17 minus x. Please don't forget your brackets. Don't forget your bracket. Very important. Whenever you're dealing with minus and you have a term that is more than one term, maybe a number that has 2 terms or more, always put your brackets. Okay, because without this bracket, this sign will not be affected, and that means you're wrong. So remember your bracket. So this is 21 minus 17 plus x, and 4 plus x. So this is 4 plus x. I will need to clean here. Okay, so now that we have filled in all these parts, now the same thing we keep doing. We add up here this plus this plus this plus this plus this plus this plus this, and we equate it to our universal set. All right, so to find all 3 languages, let me call it people that speak all 3 languages, that means H intersection Igbo intersection Yoruba. What I'm going to do is my universal set 40 will be equals to this plus this plus this. So I just add up everything. 6 plus x plus 8 minus x plus x plus 2 plus x plus 11 minus x plus 6 minus x plus 4 plus x. Alright, so just add up all the terms one by one. Add up everything, equate it to your universal set. Assuming in this case we are told that 5 people do not speak any of the languages, that means we'll have 5 outside here, and then we'll add 5 here. But in this case, they told us that everybody speaks at least 1, so that's why there's no complement here. Okay, so now if you look carefully, some things will cancel here. Minus x and plus x can cancel in many places. This minus x will cancel this plus x minus x minus x plus x. All these ones will go. So we are left with 40 is equal to, now I have, let me just write it down for clarity's sake, 6 plus 8 plus 11 plus 6 plus 4, and then I'm left with 1x. 40 is equal to 6 plus 8, 14, plus 11, 25, plus 6, 31, plus 4, 35, plus x. Okay, Now we'll collect like terms. This 35 will cross over to here. And when 35 crosses over to this side, it becomes minus 35. So 40 minus 35 is equal to x. 5 is equal to x. So therefore, 5 people speak all 3 languages. Okay, 5 people speak all 3 languages. So you can see it's quite simple. Where the work really is just filling up all these sides, and the idea remains the same. Once you fill it up, add up everything equal to your universal set, you get your missing value. And then the second question is, say people that speak Igbo alone. Now we already have an expression for Igbo alone, right? 2 plus x. 2 plus x. 2 plus x people speak Igbo alone. Alright, but we've just found out that x is equal to 5. Therefore we have that we have that number of people that speak Igbo alone will be 2 plus 5, which is equal to 7. Therefore 7 people speak Igbo alone. Okay, so is that simple? It is that simple. All right, so this is the part 1 of this video. There are other 3 set Venn diagram problems that are a bit more complicated than this. Okay, let's say these are the simpler ones. So in the second part of this video, I would solve one that is more complicated than this. Alright, although the principle is still the same, let me not even say more complicated, the one that is longer than this, that's all. But the principle remains the same. Alright, so I hope you understood today's own and you can do this. I will not give you an assignment, but you can test yourself. So maybe change some of these values and then try to solve it by yourself. You can do that by yourself. I won't give you an assignment for this. I'll give you an assignment in the next video. But on your own, you can just change some of these values and then try and see if you can solve it. Okay, so thank you so much. If you found this video helpful, like I always say, do ensure you like it. Okay, it helps with the algorithm. Okay, also drop your comments. Let me know if the video was helpful. Let me know if you have questions, whatever. Just drop a comment, let me know what's on your mind. And then, very important, share the video as much as you can to as many people as you can, wherever you can. Alright, thank you so much. If you're new and you've not subscribed, please subscribe to the channel. It won't cost you anything, but it will mean a lot to me. It's a little way of appreciating the efforts I put into making these videos. Alright, so I'll see you for the part 2 very soon, and then by next week we'll enter a new topic. Thank you so much. Keep studying math. The more you study, you find out that it's really simple. Alright, so thank you. Bye.